Hi, everyone. Many of you joined the webinar that RSRT held on August 22nd. We got over 100 questions that were asked. My colleague Bob Beans answered them, and I'm going to tackle some of them today. If you don't see your question answered, feel free to email me anytime, and I'll do my best to get back to you. Okay, so we got a number of questions about age of child. If we have an adult in their 20s, 30s, or beyond, how realistic is it that these genetic medicines that we're developing are going to help them? That's a hard question to answer. I did address it in my webinar when I said my own daughter, who's 27, I'm not expecting a cure for her, but I do think, given all of the animal data and other data that we've collected over many years, that it's reasonable to expect improvement regardless of age. How much that improvement will be and what symptoms, I think we're going to have to wait for human data. Another question, can we go for gene therapy if we're under 2 years old? So the clinical trials right now don't start that young. Most clinical trials for Rett syndrome want to wait until the child is past their regression, because doing a trial during regression could complicate the outcome. So whether that's going to hold true for future trials, we don't know. It's certainly very reasonable to expect that intervening as early as possible will give you the best results. So that may change, but for right now, it's post-regression. Updated information on the individuals that have participated in the gene therapy trials. We don't have access to that data, the companies do. So we're going to have to wait until the companies share data on their trials. Neurogene has said they'll be sharing data on their first 5 patients at the end of the year. And the next efficacy data from Taysha, I believe, is coming first half of 2025. How patients are chosen for the studies. Are they looking for children who are more or less severe? So first of all, the decision of who gets into clinical trials comes from the clinics, the directors of the various Rett syndrome clinics where the trials are taking place. It's not the companies and it's not RSRT who decides that. I think they're looking for a variety of severity levels. I don't think that they're only looking for severe or mild, but ultimately that decision is up to the clinic directors. What parents can do to increase the likelihood of their children getting into a clinical trial. These are very small studies, I think, and the demand is high. So I think these are difficult studies to get into. I also think the clinic directors are likely to pick patients that they know who live locally. And I think they're looking to, not make things too turbulent for these children, the ones that have to travel, where they're not in their school, they're not seeing their same therapist. It's difficult. They're not living in their home with all of the equipment and everything that they're used to. So I know it's hard to be patient, but I don't think it's realistic to think that everybody that wants to get into a gene therapy trial is going to have the ability to do so. Questions on whether we think cognitive development is going to improve. I certainly hope so. I think it's within the realm of possibility, but we're going to have to wait to actually see the human data from the trials. We presented a variety of genetic medicine modalities, and did we think that one was going to be superior to the other? All of them, at the end of the day, are trying to boost levels of MECP2. I think delivery, of course, will be a big component of this. How many cells can we actually hit? How many cells can actually be corrected? I think that'll be a determining factor in terms of symptom improvement. But I don't think I can say right now which one we think is going to be superior to the other. There were quite a few questions on cost. How much are these genetic medicines going to cost? Well, keep in mind that the manufacturing cost of making one dose of gene therapy using viral vectors, AAV9, is about $1.5 million. So we can expect the cost of these genetic medicines to be multi-million, 2 million, 3 million, 4 million, in large part because the cost is so expensive. Now, of course, companies are not going to expect families to be paying for this out of pocket. There wouldn't be a business model to support if families had to pay out of pocket. So they're going to be negotiating with payers, insurance companies, Medicare, Medicaid, and also outside of the US, where there's typically, at least in Europe, socialized medicine, they'll be negotiating with the governments there. Does insurance cover clinical trials? So clinical trials don't cost anything. You can get into a clinical trial for free, no cost associated with that. And that's how it should be, because after all, you are in an experiment, right? You don't know whether it's going to help your child. And so there is no cost to get into a clinical trial. There was a good question about basically burden of disease economic studies. Have we done any studies to show how much it costs to raise a child with Rett syndrome? That cost will vary from country to country. We've not done a study like that, but we think we'll be able to do those types of analyses with our Rett syndrome global registry, because we're asking questions about therapies and home renovations. And so I think, we'll be able to determine that. So again, this is a pitch to get as many families as possible to join the Rett syndrome global registry, to please fill out all of the surveys, because that way we'll be able to see what surgeries have been done, what medications your child is on, what kind of therapies they're receiving, how often. And from that information, we will be able to determine a burden of disease. How would something like base editing work? It's unclear to me how you would fix the mutation in every cell in the body. Well, I think it's going to be impossible to fix the mutation in every cell in the body. I don't think there's a delivery system that we could use. First of all, we need to hit and correct cells in the brain, not necessarily the rest of the body. This is a neurological disease, and the brain is exquisitely sensitive to MECP2. So that's our target organ. Right now, there is no delivery technology that's going to get into every cell. AAV9 gets into some parts of the brain, 10, 15% of the cells. In other parts of the brain, it's 3 to 4%. And then there's parts of the brain that it can't reach at all. Now, of course, there are huge efforts, as I mentioned in the webinar, to develop delivery technologies, whether they're viral or non-viral, that will work better than AAV9. But we don't need to hit every cell in the brain. Animal studies have shown that even if we can increase levels by 5%, there will be benefit. And then the more cells we can hit, the better. So if we can target 10%, that's going to probably provide better improvement than 5%. 20%, 25%, I think would be golden. Getting genetic medicines, whether it's trials or approved medications, to other parts of the world, certainly if there was a genetic medicine that is approved in the US, they're planning on doing trials in the UK. Neurogene's also doing a trial in Australia. So there will be efforts in parallel to try to get the genetic medicine approved outside of the US as well. Now, there may be, there will be parts of the world where it's going to be more difficult. But the companies certainly will be incentivized to try to get broad access to their medicine, because, the more people that get it, it's good for the company, also good for the patients. Do we know why these mutations happen to begin with? No, we don't. But we don't know the cause of why the genetic mutations in MECP2 happen. But we do know that, it's nature. There are mutations in lots of genes that happen. It's just, mistakes happen. But I'm not sure we're ever going to really understand why or whether there's a particular cause. How confident are we that solutions in Rett lie with the MECP2 gene? We're very, very confident about that. Now, that's not to say that there may not be some modifier genes, mutations in other genes that influence the severity of the MECP2 mutation, but we're 100% sure that Rett syndrome is caused by mutations in MECP2. And the final question is, how far out is gene editing? And are we being foolish waiting too long for interventions that are still relatively far out on the horizon? No, I don't think we're being foolish at all. I think, there are gene editing clinical trials that have already started, although not for brain disorders. But I think we could be in clinical trials by 2028. Okay, I think those are all the questions I'm going to handle today, and be on the lookout for more responses. Thank you. Bye.